We cover this session right before we dismiss from class, right? Stable and asymptotically stable. So stable means given that the initial condition is near the equilibrium point xe. Okay, near means is within the equilibrium distance of delta. Then for any time t greater than 0, it never leaves this equilibrium point too far away. Okay, the distance is always bounded. And for the unstable case, it means that no matter where you started, this one is not bounded. Bounded means it's not in the limited range. Okay. And for asymptotically stable, it means that given the same initial condition, okay, and eventually as t goes to infinity, the solution will converge to this equilibrium point. Okay, that's the main difference. Here is equal to 0, but for stable, the condition is bounded. And assume here is your equilibrium point, and you start from here x0, and after you start from here, the motion of the states is driven by fx. Okay, driven by this fx. And this fx, given the fx, you can draw the you can draw the vector field or the phase portrait, right? That give you the idea of where it's trying to go. And for a stable case, you can go anywhere around the equilibrium point, but not necessarily converge to the equilibrium point. That's for a stable case. For unstable, start from here, you can go anywhere and diverge, right? And here is not bounded. The distance between this state, which is xt, to the equilibrium point is not bounded. Okay. And for asymptotically stable, which I just write as, implies given any initial conditions x0, and you will eventually converge to the xe, which is the equilibrium point, because it's 0. Okay. Okay. And all this motion is determined by these dynamics. Okay, if that's fine, now we're going to head to the next section, which is the preliminary for reliable functions. So here we define what is positive definite function, what is positive semi-definite functions. Okay, so for the positive definite function, it implies any function which is a value function, not scalar function. Anyone knows what is the difference between scalar function and vector function? 公数有教过啊。scalar function 就是这个function是 scalar。Okay, which is scalar. For vector function, say this is a vector. Okay, this is a 2 by 2 vector. 2乘1的 column。Okay, sorry. X1 transpose X1, which is a scalar, right? And again, X1, X2 are column vectors of dimension 2. And if you write X1 plus X2, which is a vector, right, of dimension 2, then it's a vector function. This is scalar function. A function that is a scalar, a function that is a vector. Okay. And for the above function is a value function. Okay. It's this one. Even your arguments could be column vectors. Okay. So a function v here, I mean, it's a scalar function. And it's called positive definite if here are the conditions. If v0 is equal to 0, when its argument is 0, it's 0. And for the arguments is not 0, v is greater than 0. Can you imagine the function? So which one example is this, right? Right? It's 0. The value is 0 when the argument is 0. When the argument is 0, the value is 0. Right? When it's not 0, anywhere not 0 is greater than 0. Okay. What is positive semi-definite? Semi-definite means, okay, again, a 0 is 0. Okay. It's PD, and for PSD, in this case, maybe easier, a simpler case. In this case, is it 0 at 0? It's a 3D case, right? X represent X1, X2 column. So is it 0 means 0, 0 at this point? Is the v function is 0? 是吗？是吧，对不对？ What's this function looks like? So this is PD, this is PSD. So this function is similar to this. Okay. So it's 0 at 0, right? 0, this is x1, x2, and z direction is the v function. So at the origin is 0, 0, right? 有没有问题? Any other location that could be 0 for v value? Yes, on this axis and this axis, right? Whenever your x2 equal to x1, this v will be 0. Right? So, and x1 could be 1, s2 will be 2, so it's not 0. Okay, but what is, so this why is semi-definite? Because when it's 0, the only location or the only potential argument will be have to be 0. Only at one location which is 0. 只有在原点是0的时候，它才可以是0。OK， 但是在不是原点，也就是 x 等于1、2的时候，它也是0，那这样它就不是 PSD 了，这时候就叫 PSD semi， 懂吗？ So in this case, more than the origins have contained the argument that result the v to be 0, then it's PSD. Okay. But for PD case, only one point or only one argument that can lead to a zero value of v. Okay, in this case is positive definite. Okay, 你中文可以想成正函数。Okay， 这个是半正定，这个叫正定函数。Okay， and these functions are very useful to define the Lyapunov function, and they are properties to investigate the stability conclusions. And again, you have positive definite, and of course you have negative definite, and the definitions are the same. It's 0 at 0 and negative when it's non-zero. Okay, so for ND, it looks like this. Okay, with minus, you just add one more minus. Okay. Okay. Here is x squared minus x squared. And these functions could also be PD, right? And if you add minus in front of this x1 plus x2, it will be negative definite. And for negative semi-definite, it's the condition is it could be 0. It could be 0 for x is not equal to 0. Okay. Not only one argument that can lead to a zero value of v. Okay. Based on top of the previous section. Now in this section, in these slides, what I want to say is, given this PD function, positive definite function, okay, agree, right? Only at the origin, the value, v value will be 0, right? And now, given some v value, say v is equal to 3, v is equal to 1 or 1, 2, 3, okay? What are the contour of the x1 and x2? And it's called level surface. Let me just say level surface. So these three, here is a circle because of this function. It's symmetry. So it's 3 circles with different radius. Okay. So it's kind of like it takes a slice on different heights of this function. You get these 3 different contours, right? So what does this mean? This means that, okay, if I define some v function, for 3 cases. One is v x1, one is v equal to 1. Then, given this condition, what are the x1, x2? It's any x1 and x2 satisfy this condition, right? And there will be a circle, right? This circle, okay? So for any x1, x2, that You can say all these, so there are infinite number of solutions of x1 and x2 satisfy this condition, right? So that means there's a set. For in this set, where x1 is belong to a real number, x2 belong to a real number, let's satisfy this condition. Okay. And set. So this set is defined as for any x1, x2, real number x1, x2 satisfy this condition. Then I call it label set. Okay, label set. Okay, and in this case, the label set is this circle with radius of 1. Okay, and here is another label set. So I call x1, x2, x3. Okay. So did you agree? Now there's a question for Vx, x, x1, x2. Did you agree that for some y1, y2 belong to S1. So let's stop here and let's take the next slides. So and I will go back later. So in this again, this is this second slide, which is also a PD function, right? It's also positive definite, which is 0 at 0 and non-zero for V is non-zero for other way, right? So, but the label set is not circle anymore. It's kind of ellipse, okay? So, it's possible that given some label set condition, let me write down, okay, Vx again, V, when any, let's define a label set. For this to be 1, I say there's a label set S1, okay, Vx1, x2, which equal to 2. There's a label set, say 2, okay. Definition is the same. Okay, so these are labels set S1, S2. Different condition is this is equal to 1, equal to 2. The height of V is equal at 1, equal at 2. Okay, the question is brainstorming. Okay, if I give you some x2, x3, x4 belong to S1, okay, x y3, y4. Sorry. y1, y2, z1, z2 belong to S2 set. Okay, y1, y2 is in this orbit. Okay, z1, z2 is any point in this orbit, in this set. 听得懂啊 The question is it or x1, s2 is s1 plus greater than y1 square. Is this true? 你觉得这样对的吗？这个就等于 z 的 norm 嘛 ，this is equal to y norm. Y and z are some states, okay? Like x1, x2 is equal to x is defined as a vector which is composed of x1 and x2, okay? So it's condensed to one variable, okay? So it's a vector function, okay? And y1, y2, z1, z2 can be condensed to be y and z, okay? So my question is this greater than this, given that z1, z2 is in level set of s2 bar, and this is in s1 bar. Is that true or not? 懂吗？就是说，你有任意一点在这个 level surface， 跟任意一点在这个 level surface，s1 叫跟 s2， 是不是任何一点它直线距离到 origin， 就是点上任何一点，它到 origin 的距离一定会大于这个 orbit 上任何一点到原点的距离，会不会？ So this kind of the distance, any distance to the origin, right? Distance to the origin, distance to the origin. Given that y is in level set of s1, z is in level set of s2. You can consider it a satellite travel at this orbit, a different satellite travel at this orbit. Is the distance to, say, Earth, is the distance of this satellite to Earth is always greater than the satellite to the Earth. Is that true or not? True. 真的吗？直觉上是嘛，对不对？ This guy tells you that in this set, v value is greater than this set, right? V符号太多了，抱歉。Sorry, too many arguments. Let's be consistent. Y1, Y2, Z1, Z2. Otherwise, you'll be confused. Okay, it's clear, right? So label say 1 and 2, v value are different. This v value is greater than this. Okay, but this is not always true. Okay. And why? Because what you know, they can guarantee is v value is great. The v value for all argument in this set is greater than the v value, greater than the set of this v value, right? But that's v value. V value defined as this. The coefficient here is 4. But this is the norm of the argument. There is no 4 here. Okay, 懂吗？所以它的 That's why the level set, the contour of level set is ellipse, right? but the distance from the point on any orbit to the origin is not always greater than the point on a smaller orbit. Okay, for example, 我给你一个反例，这叫 S1, this is S2. Okay, greater value of V, smaller value of V. And that argument, this is Y1, Y, Z, right? Y is any point on the orbit, and let me choose. Sorry for. Okay. If I choose Y is any location on this orbit, right? So if I choose Y to be here, Y. Z to be here. And the distance of Y is this to origin, right? And the distance of Z is this. Which one is larger? Right? But what's the V value if you evaluate at this point? What's the V value of this? What's Vy? Vy is any point in this set which is equal to 1, right? Because S1. But V value of Z is 2, right? So V value, this one smaller, Y is smaller. Okay, why do I talk about this? Because remember from the first case I mentioned that you don't know the solution of a nonlinear dynamic system, right? You have no way where the state, where the point will be for any time, right? You had a vector field, you know the dynamics. You know the momentum of this x is. That means you know where it's trying to go, but you cannot guarantee the location of x for all time, right? So, but what you will know in the next few minutes is the V value. Okay, I know the V value, but I don't know what is x. And you cannot conclude that a greater V value means the larger the norm or the argument. Okay, 我们不知道这个 dynamic 的 solution， 我们解不出 x， 对不对？我解不出 x， 我就不知道说这个是大于它嘛。如果我能说，随着时间这个 norm 越来越小，也就是说，随着时间这个它的 state 越来越接近于原点，那是代表它是稳定的。所以我真的想知道是这个，但是因为我解不出这个解，我必须靠 Lyapunov function， 也就是这个 V value。这个 V value 的趋势是我知道的，我只要让它越来越小就好了。但是越来越小不代表这个东西也是越来越小 ，OK？ 因为这是 solution 嘛，你不能违背一开始讲 ，OK？ 所以常常会有 paper 这样错误引用，就是说，这个比较小，我就说它 argument 比较小，你就可以拒绝它了，懂吗？后面就不用再看了。我最喜欢遇到这种情况。Okay, so again, here's preliminary. Okay, and we will talk about stability. Then in few minutes, then it will be more clear to you. Okay, what this is about. So consider any quadratic function. Any quadratic means this structure. Okay, C1, C2 are some constant coefficients. Could be 1, 1. We just mentioned 1, 1, right? And 1, 1, 4, which is here. 1, 1, 4. Okay. And all these type of quadratic function will be positive definite because it's 0 and 0. Okay. So if z is PD, this function is PD, when at 0 and is x1, x2 will be 0, yes or no? 是吗？我们现在都要从 z value 去反推 x. Okay, we now want to investigate given z value, what is x1 and x2. So given z is 0, is x1 and x2 will be 0, true or not? 那开始怀疑自己了。It's true, right? Only solution, 0 at 0, so it's true. 然后有点颠覆你们的世界，现在开始错的吗？ So it's true. If given a level set, which z value is c, what are x1 and x2? It will be on the level set, right? And x1 and x2 could be anywhere on the orbit because their z value is the same as c. Okay, it's not at a location, it's at a set. Next, this is the question I just showed you, that given an x and y on different level set, if the level value is greater than x, the x level value will be greater than y, that term implies its distance to origin is greater than y. Okay? Okay, now another key point is if you find that at different time after a delta x and a delta y, okay, after the state change from x1 to x1 plus delta x, the z value is no. How do you find the change of this z value? How do you know given the dynamics? Okay, given the dynamics, how did you know the change of z value? 你会怎么做？我知道 I know the dynamics, right? That means I know the momentum of x, right? Can I use this condition to see what's the x plus delta z minus z? Can I know the differentiation of delta z? Can I? 可以吗？你觉得呢？如果我知道它 x 怎么移动 if I know what the momentum of the argument, can I know what's the value of z? It's possible, right? 对不对？懂吗？知道我意思吗？因为我们we don't know this solution, but if we can know the change of z, and it says z will change to 0, that means the argument reached to origin. And in this case, you don't need to solve for a solution, and it guarantees the stability, which is asymptotical stability, 对不对 ？Right? 懂我意思吗？你解不出 solution， 但是如果你知道说 z 一直减少到0，那减少到0之所以 argument 也会是0，那你就知道说，哎，那就到平衡点啦。即使我不知道它怎么移动，我只要 dynamics 就可以了，我不需要解 ODE， 对不对？对吧？哎，知道吗？知道我意思吗？Okay, is that clear? We don't need to solve for a solution, but given this ODE, we don't need to solve the solution, but use this ODE, if we can infer what's the change value of z, and if you are lucky that z will decrease to 0, then you can conclude that at 0, that argument will also be 0, right? And it's asymptotically stable, okay? And that's the spirit of the above function, which will be discussed later. So this is so for question 4, this is my intention to bridge the gap between what you learn and what is the above function. Okay. So so how do you evaluate this? Can you do this? 可以的，是可以做到。You can do this by using chain rules. if at t1 is at t0 is here, and after some t1 is here, t1, the v value which is on the z direction is changed with time, right? It decreases with time. Eventually, v will reach to 0, right? At 0, the only argument, the only possibility for the locational argument is at the origin. So how did you prove? How did you find delta v with time? You can use chain rule. So instead of finding this, we find the time derivative of v, okay, which is defined as dt dv, right? Anyone in the world know this? Use chain rule. What will you put in here? X, right? You have no choice, X. So what is this? The dynamics, right? Dynamics. V, once you define the V, this automatically pop out, right? For example, if your V is x1 squared, it's just gradient. Gradient is a gradient defined as partial V partial is equal to partial V partial x. Okay， 因为 v 的 argument v 是 x 的函数嘛，所以你 gradient 一定是对 x 做 gradient， 不会有 t。So what's this? It's 2x. Again, because you have two arguments, right? Okay, so there will be a column vector. So what's this? V is this. Partial is with respect to x1. That's 2x1. It's 2x2. So it's known. Okay, and this is known. So this, the trend, the time derivative of v is known. Okay. And if the time derivative is negative, if this is PD, okay, positive definite, which says is 0 only at 0, and if V is negative definite for x not equal to 0, okay, if x is not equal to 0, that means anywhere other than 0, which is here and here, is always decrease. Then you can say, given these two conditions, given 1 and 2, V will reach to 0 as t goes to 0. 对不对? Right. So, and if V is 0, and V is PD, right? V is PD. This condition guarantees V converge to 0. Your x converge to 0, right? So it's asymptotically stable. Okay, 能懂吗? So again, did you solve the solution of ODE? No. We substitute to this chain rule and evaluate this value is positive or negative. So in this process, you did not solve any ODE. Okay. So this is the way we evaluate the differentiation of z with time. From 4, can you utilize? Okay. This means the gradient slope of gradient. Okay, so which is this part. For this is Lyapunov functions, Lyapunov series. Okay, so it says given x equal to 0, be an equivalent point. So the Lyapunov function says given x 0, which is a equivalent point. Okay. At x equal to 0 is an equivalent point for an autonomous system. Autonomous system, which we defined before, that is this f doesn't explicitly depend on time, only depend on states. Okay. Define x equal to fx. Otherwise, and for non-autonomous system is f, x, and t. Okay, explicitly depend on time. But here we consider that for autonomous systems. So their phase posture is stationary. Okay, doesn't change with time. Remember, right? D is a set belong to Rn. Okay. Be the domain containing a real region. Say this is D. N dimension. In this case, it's 2D, right? X1, X2, so it's 2D. And this domain D contains the region Xe. Then let a function V mapping from D to R. Okay, so mapping means you map an argument to the value of the function, right? It's kind of like fx. You map x to fx, right? Okay, like a machine, like a vendor machine, 投影机. You put your coin, right? Put your coin inside. Coin is your x. fx is your beverage, 你的饮料，对不对? So this is your input, and you will get some value, which is called fx, okay, or y. Sometimes, usually, but general is fx. And this is the domain of your argument or your input. This is the domain of your output. For the overall function, it's a value function. So this one had to be one dimension. Okay, but input could be R1, R2 to Rn in general, depend on what the dimension x is. In this case, it's D, right? Because D is the is your state. Okay, this domain is for the states D, so it's mapping from D to some value function. Okay, 听懂吗？这有问题吗？没有吧？好。Okay. So V had to be continually differentiable function. Otherwise, remember, it had to be continually differentiable, C1. Otherwise, the solution is not unique, right? So if this satisfies, the solution of this V exists and is unique, 对不对? It's C1. But if it only satisfies C0, the solution only exists, but not unique. Okay? Okay. So the initial condition for V is V0 at 0, and V is greater than 0. This is PD, the requirement for a PD function. 对不对? 0 at 0 and greater than 0 when it's not 0. D subtract element 0. Okay, D is this domain, but not include this. So anywhere in this domain that and exclude this, the value of Vx has to be greater than 0. It's kind of like this. Okay? And in this case, if you can find this V and you know the time derivative of V is negative, means V value always decrease, okay? Then your X at 0 is stable. So in this case it's stable because V dot is negative. V dot is negative, that includes D. And remember D contains X0, right? But in the second condition, D subtract 0, D excludes 0. Okay, Dx should be less than equal to 0, okay, in D. And this condition is called PNSD, okay? So maybe let's go back to a few slides what the for the definition of SD, which here, right, less than equal, okay, for x not equal to 0, less than equal, okay, sorry. So that means given a PD function and your V dot could be equal to 0, this means could be equal to 0 when it's not at the origin, say here. Maybe at here, okay, at here, which is not at origin, and V dot at this point is 0, means it stopped decreasing, right? It keep at this level set, and in this level set, we know the argument is not trying going to the origin. It stopped here in this orbit, which is not 0. So it's only stable. It doesn't go anywhere. It doesn't go outside of this orbit. Just keep staying on this orbit, right? Because V dot is 0. V is constant, right? V is constant means it's a level set, right? Level set means the set containing all the states or all the argument, 对吧？听得懂啊？ level set 不是切个 slice 吗？ And all the argument on the orbit is a level set, and which means when V dot equal to 0, V is constant. V constant means V is some value. Okay, so the X is in the level set. Okay, 没有问题。那这时候 V 就不变了啊 ，V 不变表示说这时候我的 X 我用 V 去反推 X 嘛，这时候所有的 X 都满足这个 V value， 那也就是所有的 X 都待在这个 orbit， 它不会再往 origin 跑了，对不对 ？Okay, so it's called stable. But if you can find a condition that it always decreasing outside the origin, okay, always decreasing any point outside this origin, V is always decrease. Eventually, V will reach to 0, right? 对不对？哪里听不懂 ？Is it two mathematical symbols or what? 哪边不懂？浩平哪边不懂？没有，都不懂。哪边不懂 ？Bruce。 不包含。D is a set like so for example D is a set D subtract 1 is 2, 3, 4. 能懂吗 ？Okay. Basically, this function is a virtual function, right? This default function doesn't exist. It doesn't have any physical meaning, right? 对不对？你自己创造一个函数嘛。What is what is physically exist is the dynamics of a car or a mechanical system. This exists， 对不对？对吧？这是存在的，这是你用来 model 一个 dynamics， 一个 physical system， right？ And based on this, you can plot the face portrait， 对不对？你可以 plot 一个 face portrait， 对不对？这是上一次的 homework one, right? You can plot a face portrait. So assume this is 0, 0, and you start anywhere from here. Initial condition is here. And use this face portrait, you can plot the trajectory. You can plot the trajectory of the state with time. 这没有问题吧？这边没有问题嘛？ Okay. But we have no idea what the solution to this ODE is. We don't know what this trajectory is. Therefore, we define a level function in the z direction. Okay. And each point on the x1, x2 plane have a mapping, right? If you define this function, you can choose the function. For example, this x1 squared, x2 squared, or whatever is positive definite, right? But in this example, for x1 squared, x2 squared, it's this kind of shape, right? Right? So everything in yellow is virtual. And why you utilize this function is, given any point here, okay, here, given any point here, that, and according to this vector field, there is a, this vector describes the motion of this state at this location, 对不对？那 if you project or substitute this function, you will get a v value, which is of this z-axis, right? 对不对？ And our objective or our hope is trying to see if this v value will decrease along the trajectory. Because we know if you keep decreasing along the trajectory, eventually v will reach to 0. So does the states, right? 就刚讲的嘛，对吧？刚刚不是讲的吗？刚讲说，v dot equal to vx times the dynamics, right? And we want to evaluate if this is negative. Because when it's negative, okay, if it's negative, that means this value keep decreasing. And this value means maybe at t1, x is here. And using this corresponding vector field, t2 is here. And t1, t2, these states have a different v value, maybe here. Right? They have different value. And you compare the two. If this is smaller than the previous one, we say a v dot maybe is negative, right? And if that's also the case, eventually it will reach the 0, right? And based on this function, the 0 value of v means x1, x2 are 0, which converge to the origin, 对不对？所以不管你在哪里 no matter where you are, if v is 0, that means this trajectory converge to the origin, and this means asymptotical stability, 对吧？是不是？懂吗？ So we don't need to solve the solution, we just evaluate this. So all the property is condensed to this property, okay? 懂吗？哪边不懂？因为我不 care 那个不能在0的地方等于0。如果你在，你说第二个 case 还是第一个？都一样。为什么 我目的是要让不管它在哪一个 x， 它 v 都是往下的，也就是 v 都是小于0的。所以我想要 v 小于0，不管它在哪里嘛，除了原点以外的地方，我 v 不管在哪个点，我要找到的 v dot 它是小于0的，表示说不管在哪里，它都会偏吸到原点，对不对？对吧？And 浩平懂吗？品线懂吗？
所以那个渐进稳定是稳定的一种吗？
就更好的一种啊，就是 converge to zero 啊。
所以它是被包含在
渐进稳定是这个。这个是渐进稳定，它会收敛到平衡点，这个是收敛到平衡点的附近。
可是这样的话，就变成说，就是渐进稳定应该是包含在 stable
包含在 stable 里面，不一定啊。如果你是渐进稳定，你是 stable 不一定代表渐进稳定嘛。但是你渐进稳定一定是 stable， 对不对？所以，对。The reason you put equal sign here is it's stable. Stable means it doesn't converge to zero, but it doesn't go anywhere， 对不对？你看一下 label set 这个嘛，你投影到 z plane， 我们讲过，这个是 z 方向是不存在的，它是必须 you need to project to this x1 x2 plane, right? Because it physically exists, but not in the z direction. Z is only for your reference. Okay. 所以如果if v dot is zero, if v dot is zero in some d in here, okay, if v dot is zero here, that means that v is constant. And when v is constant, x1, x2 could be any value satisfy, for example, 1, right? 这时候你的 x1, x2 有很多 value 嘛，就是任何 value 在这个 orbit， 它的 value v value 是等于1的时候嘛，对不对？这些点都符合嘛？那这些点是等于0吗？不是嘛，它是在 D 里面嘛。OK， 那这时候不就是 stable 啊？因为它不到平衡点嘛，它在这里。It's not converge to zero. It's stay away from zero, but it doesn't go anywhere, so it's stable， 对不对？So you put equal sign here, but here there is no equal sign. It was forced to be negative. Means the only chance is you had to decrease no matter where you are, other than zero. 对不对？懂吗？因为我要的是 asymptotically stable 嘛，我要你强制收敛到这里，所以除了这一点以外，其他的 v 大一定要是0嘛，一定要是小于0吗？对不对？懂吗？到底哪里还有哪里不懂？哪边怪怪？是太数学吗？你去看课本也是这样写，你去翻那个 Bible, the nonlinear control Bible is described in the same way. Okay. Maybe you consider this first, and go back to here is easier. So no matter where you are, other than origin, okay, the corresponding v dot had to be negative, so it had to decrease. 那这样一定会收敛到这个点 ，OK。那当你画一个等于0的时候，表示说它还没有到原点之前，它就 stopped。V is constant because v dot is zero, then v is constant. So x the state in the level set, which the projection on here to the face portrait is anywhere in this. It doesn't go to the origin, so it's stable, right? 软虫洞有没有问题 ？Is that okay to you?
Yes.
So someone understands, someone don't understand. So raise your hand, ask question if you don't understand. Otherwise, it's the last chance. 尽量问啊，赶快！你不懂后面你就不懂了。
那如果那个小于等于零那个，如果变成直接等于零的那个 case，
那这样你一放上去它就不动了，对不对？
那当然它是算 stable。
If it's 0 means anywhere in D, that means no matter where you start here and it just stay here, it doesn't go anywhere. There's no dynamics, right? The dynamics can be if V dot is 0 in D means V dot 0 means V is constant. V is constant. X is in the level set. In the level set. So depend on what your initial location is. Okay, the level set is any orbit with V value at here. Okay, V value at here. 这样懂吗？所以一放上去，它就开始存在这里面，在哪里我不知道，因为我不知道 solution。I don't know the solution of x, but what I know is in this orbit because V value is constant. 这样懂吗？ So it have to decrease, but it stop decrease somewhere before it reach to 0. Then it's stable. 懂吗？它没有走到 0 之前，也就是它在半途 D 的时候 ，D 就是 include 还没有到 0 嘛。它就可能等于0了。V dot is equal to 0 means V become a constant， 懂吗？这时候它就是 stable， 因为它就是在这边嘛，它不会去 origin， 它也不会 go away， 所以它就是 stable， 这样懂吗？这样也比较清楚吗？我不知道你的不懂的点，所以你要问问题。
因为他之前不是讲那个 living cycle， 就是它还有一种 stable， 它会
对。So if you substitute the solution or the dynamics of limit cycle to some level function, okay, you will get this. You will get V dot equal to 0, okay, because it's in the level set. 懂吗？ But it's a necessary condition. You don't know the trajectory. Anywhere in here could be the potential location. 还有问题吗？但是你看这个就很明显，这个一定没问题嘛，对不对？强制它 decrease 嘛，所以它 decrease until it reach to 0 嘛，懂吗？所以它一定是渐进稳定。OK， 其他还有问题吗 ？OK， so here I just mentioned here, right? Use the chain rule. So in general, there's a term called the derivative. So given a dynamic system, okay, it's kind of like f equal to some ODE. And if you choose a level function which is PD, then its time derivative v dot is equal to this. Okay, use chain rule. So on the right hand side, the x dot here is the dynamics, so you can substitute minus x, right? Substitute your x dot is here, so you substitute minus x. And the gradient of v is x, right? You take the gradient, is x. So what you get is minus x squared. What does that mean? Minus x squared means anywhere if x is not 0, this guy decrease. This guy is negative, and this guy have to decrease. 对不对? And the dynamics of x dot equal minus x. Assuming you don't know the solution, okay? But in fact, you can solve for this linear ODE. But assuming you don't know the solution, so evaluate at this point x equal to 1. We know x dot is minus 1, which means it's trying to go back to the origin. Okay? And if you evaluate v value here, what's the v value here? When x equal to 1, you substitute to the default function. That would be 1 over 2, 对不对？对吧？那你觉得呢？你觉得 if you use this dynamics, what would be v dot? 看图就知道，对不对？ Because you're trying to move back. So if you move to next time, if it's here, v value will be smaller, maybe 1.25, 0.25. So in this, based on this figure, you know it's negative. But if you use numerical measure, it tells you at x equal to 1, the v dot is -1. And this fact matches this observation, right? 对不对？两个是符合的嘛，没错嘛，懂我意思吗？你看图就知道嘛，because 它一定会往这边 move 嘛。Based on this dynamics, right? You substitute one here. The x dot is -1. X dot is motion, and it's trying to go back to the left, -1, right? 所以当它移到这里的时候，它投影的这个 v 值一定会往下嘛，因为它投影到这个线上嘛，这个点投影到这个线上会到哪里？这里嘛 ，right？ 它这个值不是比原来的还要小吗？对啊，所以随着时间变化，它的 v 值会下降嘛，也就是 v dot是 negative， 懂吗？懂吗？啊，什么时候会等于0？什么时候会等于0？就对不对？所以我们上一页才把那个 zero exclude 掉，这样懂吗？这样懂吗？ So the reason we exclude 0 here is because in this case, at the origin, okay, the gradient of this function is 0. The slope is 0. So that means your v dot will be 0. That's why we exclude 0. Okay, 看到吗？最小值嘛，一个 function 的最小值，它的 gradient， 它的 slope 不是 0 吗？对不对？它的 slope 是 0， 那 v dot 一定是 0 嘛。Okay, okay. So is that clear? To this example, it's a one dimension. Okay. So basically, this part, this v function doesn't exist physically, right? It just help you to analyze the stability. Okay. So this is a gradient, okay, of this function, this virtual function. Okay. And the second part is the dynamics of this. The second part is associated with the physical dynamics, okay, which is this part, okay. 能懂吗? Okay. So what is the gradient of this function at this point? There will be physically, if you use visualization, it's this slope, right? 对不对 ？Gradient 啊 ，gradient 不是斜率吗？这个 function 对 x 的斜率啊，对吧 ？So what's this? Gradient of this is x, and substitute x equal to 1, which will be 1. Okay, the slope is 1. It's 1. It's positive. Okay, it's positive. That means if you move to the right, if this dynamic is trying to move to the right, if this is positive, okay, move to the right means it's positive. This guy will increase, right? Because it moved to the right. Based on the slope, you will reach to this value. So v will increase, 对吧? The physical meaning of this v dot. the motion of a state, the configuration or the slope of this configuration, 对吧？对吧？ So if you move to the left, which point to the negative direction, v dot will decrease, okay? Because you will reach to here, and the corresponding v value is decrease. 这样懂吗？所以下一张okay. So in this figure, this is phase portrait, okay? Phase portrait. This is the gradient of v function. Okay. This is the dynamics. X delta t. If when you multiply two vectors together, it's a dot product, right? 内积，你把两个向量做内积，你把两个 if you make a dot product and you prefer this guy to be 0, right? Means the two had to be in the opposite direction, 对不对? Right? So, given such kind of function, the gradient is point outwards. The gradient of this kind of function is point outwards, right? 懂吗？你们学材料力学应该知道吧？一个体积，一个表面积的 gradient， 它当然是指向外面嘛，对吧？对吧？ Okay, point outwards. And if you want your v to decrease, the dynamics, the vector of this dynamics have to be in the opposite direction of your gradient. Means your x had to point inwards. Okay. So what does that mean? Your dynamics had to point inwards. 对这个体积而言，它的里面是什么？指向圆心，对不对？ So in this configuration, point inward for x dot point inward means it's trying to reach the origin, right? And in this case, your gradient and your dynamics are in a different direction, and which case v dot is decreasing. Okay, 这样懂吗 ？Okay. And this all these slides are trying to say. Okay, 这样懂吗 ？So this configuration is very virtual, okay? What really exists is this trajectory. This is the dynamics of a physical system. But you create a virtual function which gradient is point outwards. And you can say, because I don't want to solve I cannot solve the solution, but I can know from its dynamics that if this dynamics which associate with the vector field or the momentum that state trying to move, if this direction is point in a different direction of my gradient, I'm safe. I will eventually converge to the origin. 这样懂吗? Okay, another example. So given a dynamics an autonomous system x1, x2, okay, 2D in a 2D space. 你有一个 x1 dot x2 dot described by these ODEs. Okay, is this system stable? And this is a question. This is usually an engineering question, right? You have model a mechanical system that give you this kind of dynamics, and the question to ask is this what is the equilibrium point? Is this system stable or asymptotically stable or unstable? It might be hard to solve this solution, but Lyapunov function or Lyapunov theory could be the tool to evaluate stability for this kind of system. Okay, we don't know the solution of this system, but we have the dynamics, and you can apply to the Lyapunov theories. Okay, so what you will do is first evaluate equilibrium point. So, and in this case, equilibrium point is 0, 0 because you that this equation to be 0, that this equation to be 0, you can solve for the solution of x1, x2, which is 0, 0. Okay. Next, you have to find a Lyapunov function. Okay. if this Lyapunov function doesn't fit, try another Lyapunov function. There is no systematical way to find the Lyapunov function. But if it's a linear system, then you are lucky. You can use LMI, which stands for linear matrix inequality. To find the Lyapunov function. Okay, but for nonlinear system, usually it's hard to find. Inequality. Okay. So we can search for this keyword. Okay, if you're interested. But here we just randomly pick up or design the Lyapunov function. Okay, and try what's the v dot. So the first step is you take the gradient. You take the gradient of v. Okay. So this is PD, right? Positive definite, okay. And x dot. So what is gradient of v? Gradient of v is right? 对不对? Okay, so this x1, x2. What is Vx? Is that dynamics? Right? Okay, so you multiply the two. Gradient. Okay. Sorry. After you take a gradient, this will be a row vector, not column vector. So your v dot will be x1, x2 times this guy. Okay. That will be what? 这样相乘会等于什么? Will be x1, x2 minus x1 squared. Okay. Plus the second part, x2, x1, x2 minus x2 square, x1 square. Okay, and one， 我有写错吗？这个吗？为什么？为什么？ Let me put minus here. It's negative definite. V is PD. V dot is ND. That is AS. Okay. Okay. 能懂吗？所以 So you don't need to evaluate this. You don't need to solve the solution. But now you know x1, x2 will go to the origin in time as t go to infinity. Okay. 这样没问题。No matter where you started. 好。Okay. 有没有问题？ So if you don't believe, what you can do is x1, x2, and plot out. Maybe you plot here. Choose any initial condition, okay, and see what's the vector field according to the dynamics. Okay. Based on these two, you can construct the vector field, and you point out evaluate at every point. Eventually, they will converge to the origin. Okay. Okay, and what we do here is we construct this Lyapunov function, which is again like a ball. Okay. And we know that given these dynamics, okay, the projection of the v values is always decreasing along the dynamics. Okay, it's keep decreasing because beta is negative, definitely. No matter where you are, right? You substitute at this location and this location, you substitute. It's always positive and always negative, right? So beta is always decreased. And based on this configuration is positive, definite. The only chance for zero Lyapunov function is at the origin. Okay. So a question for you. This is PD, right? But if you choose a Lyapunov function that is PSD, this is PSD, right? Because no, it's still PD. 这个也是 PD 嘛？它只有在0的时候才是0嘛，其他地方不是0。Okay, so this is also PD. It's only 0 at 0. But if you choose this kind of Lyapunov function, you will be in trouble, right? Because how many minima do you have? You have C1, 2, 3 local minimas. What happened at this local minima is this is equal to 0 at this local minima because this stands for the slope, right? And the minima, the slope is 0. So if you are not, if possible, you don't want to choose this kind of Lyapunov function. Okay, even it's PD, but it's not a good Lyapunov function. Okay, 懂吗？因为你证明出来，它一定会是 PSD 的。你光看图就知道它一定会 PSD 嘛。He will get stuck at somewhere that is not 0. So it must be PSD, even your system is stable or asymptotically stable. Okay, that's for today. Thank you.